We're going to look at part 2 of simplifying radical expressions. First, let's talk about what a cube root is. So if we're thinking about a cube root, well, when we were talking about a square root, we were looking for a number that multiplied by itself twice gave me that. So the square root of 25 was 5 because we know that 5 squared is 25, and the square root and the square are like opposites of each other. They cancel each other out, and so we're left with 5. So with the cubed root, we've got this little 3 out here. Let's say the cubed root of 8. We're looking for a number that multiplied by itself 3 times gives me 8. So think about, what is 2 times 2 times 2? Well, 2 times 2 is 4. 4 times another 2 is 8. So we know that 2 cubed is the same thing as 8. So if I take the cubed root of 8, or I take the cubed root of 2 to the third power, my answer is 2. Okay, so let's look at some more. Let's simplify 343. So similarly, like we broke down the other one into square roots, we want to break this one down into cube roots so that we can simplify it. I'm going to make a list here. So I'm going to pause the video and make a list of perfect cubes. Okay, so I've listed the first 10 perfect cubes. I have listed the first 10 perfect cubes here, and as you can see, here's one on here. 343 is a perfect cube, and it's the 1, 2, 3, 4, 5, 6, 7th one down. So we can check it on your calculator and see, but 7 cubed is 343. So the cubed root of 7 cubed is 7. Okay, let's try the cubed root of 135. Well, we're not so lucky this time, right? 135 is not on here. But we can see, is 135 divisible by any of these numbers that are perfect cubes? So think about it here. 135, we can do the prime factorization if we want. So 135 divided by 2 doesn't work, but what's 135 divided by 3? Well, 135 divided by 3 is 45. So let's try to break down 45 now. 45 is the same as 9 times 5. We can break down 9 into 3 times 3. And look at that. We've got 3 times 3 times 3 times 5. So if I think about that, I have 3 cubed, right? 3 cubed times 5. So the cubed root and the cube on the 3's cancel, so I'm left with 3 times the cubed root of 5. All right, let's try another one. We're going to simplify more problems involving cubed roots. So we could go ahead and leave that 2 there if you want and do the prime factorization of 36. Remember, prime numbers are numbers that are only divisible by themselves in 1. So 36 divided by 2 is 18. We can break 18 down into 2 and 9, and we know that 9 breaks down into 3 times 3. So we've already got this cubed root of 2. And now 36 is the same as 2 times 2 times 3 times 3. So how many 2's do we have? Yay, we have 3 of them. So I'm going to rewrite this as 2 cubed times 3 squared. So, of course, the cubed root and the cube on the 2 cancel out, and I'm left with 2 times the cubed root of 3 squared, or 9. And that is the simplified version. Okay, let's do 168 over 375. So I'm looking again. None of those are perfect cubes, so we're going to break it apart, do the prime factorization. Okay, so I have it broken down. I can see that there are 3 2's. 2 times 2 times 2 times 3 times 7 is 168. So since there's 3 of the 2's, I'm going to pull it outside of the cubed root, and then I'm left with 3 times 7, which is 21. Okay, I broke down 375. Look how many 5's I have. 1, 2, 3. I'm taking the cubed root, so I'm going to pull that 5 out, and I'm left with the cubed root of 3. So my answer simplifies to, it's not very pretty, is it? 2 times the cubed root of 21 times the cubed root of 3. Now we could leave this. Remember, we just had 3 and 7. So we have 2 times 3 times 7. And over here we have 5 times the cubed root of 3. Why would I want to do that? Well, when I have the same thing on top and bottom, they cancel. So I'm left with 2 times the cubed root of 7 all over 5. And this is the simplified answer. All right, moving on to the next one, the very last one. Let's go ahead and try to do the prime factorization. Didn't mean to do that. Do the prime factorization and break it apart. I'm going to pause the video, and I hope that you do too, and that you try this on your own. All right, so far I've rewritten the top. Now I'm going to rewrite the bottom. So I have the cube root of 3, 3, 3. How many 3s do I have? I have 4 of them. So I've got 3 to the third times 3. And then I have times x to the third times x to the second. Notice I tried to break all of these up so that I had 3's wherever possible. So the cubed root of 3 and 5 and x squared and the z I can't do, but I can take the cubed root of the y cubed and z cubed. So I have yz on the outside. And then underneath of here, we have the cubed root of 3 times the cubed root of 5 times the cubed root of x squared times the cubed root of z, all left underneath of there. On the bottom, we can pull out a 3 and an x. So I have a 3 and an x times the cubed root of 3 and x squared. Look what happens. I have a cubed root of 3 on top and a cubed root of x squared on top, so those cancel. So I'm left with y times z times the cubed root of 5z on top. And in the denominator, I'm left with 3x because the cubed root of 3x squared canceled with the one on the top. So this is my simplified answer. I hope that made sense. Again, if you have any questions, reach out to me and let me know, and I will do my best to help you. Have a great day, guys.